Okay, so this is a problem about half-life, and I know that half-life means its length of time it takes for a substance to decay by half. They're telling us the half-life of carbon-14 is 5730 years. So I know that when I'm dealing with these exponential growth equations, I can write these as annual growth form. I can also write these as exponential or continuous growth form. Okay, R, K, I mean, we can use. I'm going to choose to do it this way today, just because I feel like doing that. So I know that if it decayed, if it's a half-life, if I divide what's left here by what I initially started with, that better be 1/2. That's telling me I have half the substance left at some annual growth rate, and because this is carbon-14, that's taken 5,730 years. So to find the base, all I have to do is I have to raise 1/2. I'm going to take the one, remember how we can take the reciprocal, raise it to the reciprocal power, and that's like taking the root. Taking the square root of something the same as raising it to the 1/2 power. And that's what we're going to do here with this awful number. So I'm going to raise 1/2 to the 1 over 5730, and that should be the base. Okay, so I'll get my calculator here. I'm going to put my microphone back in. So I'm going to raise 1/2 to the, and I got to make sure I use parentheses, divided by 5730. Did I get that typed in correctly? So that's the base. So this allows me to write this equation. If I want to know the amount of something, or actually how about we use C for carbon-14. So the amount of carbon-14 based on time is equal to 100% of the percentage of carbon-14. 100 times, let's see, 0.999879. We'll go that many decimal places to the t power. And now we want to know, when is there going to be 60% left? So when is 60%? That just sets us up like that. We replace it with y. We're going to divide by 100, which gives us 0.6. And then because the exponent, the t is the exponent, locks up, we're going to use logarithms to solve this exponential equation. Missing a 9. 879 to the t, and then because I am taking the log of both sides, and I have that logarithm of that exponent on this side here, I can use that power property of logarithms to slide that in front. Then to solve this, I'm just going to divide both sides of this equation by the log of that awful number that I've written about 10 times. That should be what t is. Let's see what the calculator tells me. Move some windows around here. So let's see. Log of 0.6 divided by the log of 0.999. I could probably just use the value that's on the calculator, but I've got this half typed. So I'm getting 4,221. I think the answer in the back of the book is 4222. So this is just a rounding situation that's happening. Okay, but that's how you find a half-life, find the amount, the percentage when they tell you some half-life amount that's left. Okay.